like Kenny said, I'm Scott Clousing. My dad started this idea very much like you guys 50 years ago. My brother Steve Clousing, through the years we've done everything from sweep floors to build buildings to you name it, we've done it. I don't know what you guys know or don't know about this whole contraption, but we've done it a long time. The basics of it, you know, you have literature in your hands, but anywhere from a 24-foot building to a 100-foot clear span. All of those buildings model what you're going to see today. It doesn't matter if it's a 24-foot building or a 100-foot building. It's the same set of rules, same steel frame, same wood that hooks to it, same dimensions, all that. It's just obviously a bigger frame along the way. So as we get through today, you'll learn some of that. And hopefully if you have, like, I call them real questions. You guys are construction people, we're construction people. You know, ask why that 1.5 inches there or why that 2 inches there. That's what I have grown up doing, and I hope to fill you guys in on what's what.
I'd like to start over here. Kenny says you guys, everybody got, we can come over here if we want, that you guys got the email with the erection manual. If you have time to look at it or not, there is basically any building, as easy as it sounds, the saw and nail gun plus these tools, basically is what you need to build a building. Obviously you need more wrenches the bigger the building, whatnot, but very straightforward. As we go through, like Scott said, there's not such thing as a dumb question. Feel free to stop one of us or in the middle of what we're doing. We can answer it. To start the project, that 2x10 skirt board, we put that up with the dimensions, and it is, you put them out there with form stakes to hold that up, and this is what we use to form our pier, our concrete pier on the inside.
We can set any building on piers. Obviously, a foundation wall is also an option, or a monoslab, all the same concrete options, but structurally, a pier, which these metal boxes are a representative of a pier. A standard building to us is a 15-foot bay. From you know, red iron to red iron is 15 foot. Unless we get way up into Michigan or snow loads, that 15-foot bay could turn to a 12-foot bay or a 10-foot bay to get a really, really heavy snow load. Same frame, just different bay spacings. So again, everything we talk about today is going to be the center to center dimension is what is important as we make the lumber to set the frames and all of that. But the pier, if you were going to a job site to pour piers, this little mock-up that we have right here, we have the 2x10 band board going from pier to pier. That is not how we would do the job site. We would have, there's an intermediate post that we bury, and then the 2x10 would be a 15-foot 2x10 from wood post to wood post, and then we hang the 3-sided box on the inside of that band board, and that's what you pour your concrete to, and then pull the box back off. And then the pier, there is no 2x10 treated splice at the pier. The splice is at the post. So all you do is you stretch a string, you hang your boards on the string, you nail it to the post, and then when we pour our piers at the 2x10, then you just pull that form and you're done. Foundation is done. Typically a pier job, if it's a 70 by 120 and smaller, that's going to be a one-day pier job, one-day concrete job for piers. Of course, foundation walls are what they are. These are a little different because the board is going from pier to pier. We have to put that there so the X-bracing works out later, so we have something to space it apart. But a little bit different what we have here to reality what the job site would be, but at the end of the day, piers are quick and simple. As far as timing and dollars that it adds or doesn't to the building. If you want to make it simple, there's two different sizes of piers, an 18-inch pier and a 24-inch pier. 70-foot and smaller is an 18-inch pier. 80-foot and bigger is a 24-inch round pier, 40 inches deep, build the bottom out. An 18-inch pier is about 1/3 of a yard of concrete. 24-inch pier is about 1/2 yard of concrete. That gets you a long way. Now, once you get into a specific job and what soil you have, you know, there's a lot of questions there, but that's the generality of what a pier is. So really, the dollars and cents of a pier is very similar to a permacolumn as far as cost.
If you look at the papers I hand out, the second page has got a generic, if you will, drawing of a pier foundation, and you'll see on the left-hand side, that's that intermediate post Scott was talking about. That's where that 2x10 skirt board would splice. That way, when we get to our mainframe, it's one continuous board going through that pier.
That post isn't structural in any way. It's just a place to splice that board. It's not anything structural with the building at all.
This would be a mainframe pier right here, and this one we got bent is for the corner. This would be on, you would fasten this board here, and then when your skirt board goes over here on the end wall is where you'd have that corner fastened too.
We have those, we'll call them pier boxes, made up. They get reused. We've got some that are new, some that are 10 years old. You know, just a typical form.
Since we're on the subject of piers, after you get the box fastened to that board, just an L bolt will drill that in there, and then that way it's in the concrete. This is what will fasten that 2x to the concrete when it's done.
You pour the pier, pour concrete, you know, let it cure and all that, and then when you build the building, tighten those nuts up. These are
The anchor bolts that go, this is the main frame, and that's the end wall. We just wet set them is all we do. Every drawing, every building will have a drawing for the dimensions for these, how far off of the lumber each way.
A lot of people are, I'll say, nervous about anchor bolts, especially when it comes to all steel buildings. That anchor bolt's got to be just right there because the secondary framing is cut to length and the bolts won't match. With our building, so this building mock-up is 15 foot on center, but that anchor bolt that you would set in the concrete is a U-bolt. Now it's a 4-inch center bolt, and we want 15 foot is centered on that 4 inches, so we're going to bury that, and I run a tape down the 2x10, put a mark at 15 foot, and I bury this anchor bolt centered on that mark, just by sight. Because with the secondary lumber, if this bay spacing is supposed to be 15 foot, but it ends up being 14, 11 and 3/4 by some happens, when you go to set the building, you just measure what that is, and we make the set board, which we'll show you here in a little while. We just change the length of that board by a 1/4 inch, and so the anchor bolts are very easy to set. There's a lot of forgiveness if you don't get it exactly, you know, where the drawing says. In a steel building, if you mess that up by an inch, you're cutting girts and trying to get the thing drilled, and it's just a real big headache, where this really is a non-issue.
If you go to the next page, the last page, this is just, once again, the top one is the pier, like what we're dealing with here. It all lays it out there where the skirt board is, the anchor bolt, etc. The bottom one is a footed wall foundation, just to kind of get your eyes wrapped around what we're doing. Now, when you get your concrete drawings, the dimensions, let's just say if the building is 40 foot wide on a pier building, it's from the outside of the treated to the outside of the treated, that 40 foot dimension. On the foundation wall, it's actually the concrete is 40 foot. Because you have foundation wall, you're gonna have actually a sill plate like what you guys are used to. So, okay, backtrack a little bit. The front page, when you guys get a building delivery, you'll have a hardware box as such. If there's multiple buildings on the load, the box will have the job name on the box. That's how you're gonna be able to keep track. And anything that's on this front page will be in this box. Nails, bolts, the anchors. This is because you guys are receiving iron only. This, you only get one page. So, and at the top, you'll recognize it's got the job name up there too, that'll match that box.
That box is plastic. We kind of use it as a job site warehouse that stays dry. So you can put drawings in there, everything that, as far as information and hardware, is in there, and you can put the lid on it, and if it's raining today, it stays nice. I operate on like a K building set of rules. 15 foot on center is one of the big, if you just remember that, you get about 50% of the job done. Everything that we do as far as making lumber, setting frames, pulling dimensions is all based on 15 foot center to center. As these frames get bigger in clear span, obviously this is just a miniature little thing that we made up, but you know, the dimension of the frame. So the thickness of the frame, you know, this one's 3.5 inches. As they get bigger, that dimension will get thicker. So some of the lumber lengths are going to change, but the 15 foot on center is what you're, so as long as you keep that in your head, that's, and once we get the brace base set, then you're just adding 15 foot. So
Is there a max snow load that this will comply to?
currently 70 pounds, back to changing the base spacing. If we go to a 10 foot base spacing, 70 pound. 15 foot base spacing, 30 pound. Basically, it's governed by lumber. The secondary lumber is what's driving that number. Do we ever get heavier than that? If we go south, it'll be less snow but more wind. So it kind of goes hand in hand. But the frame, let's say we're working on a 70 foot wide building. A 70 foot frame is pretty much a 70 foot frame. What we would call a standard frame or a commercial frame. Commercial's a little bit different as far as welding goes. But if it's a 70 foot frame in a 30 pound building or a 70 foot frame in a 70 pound building, it's the same frame. Same dimensions, same different base spacings, but everything else is the same. The only thing that would change from a 30 pound building to a 70 pound building would be the length of the wind rods because the base spacings change. But yeah, so we're trying not to have to redo like the frame engineering because there's a lot to that. We just take that same thing and make it more, we've got way up into 70 pound buildings are fairly new. We've got 3 or 4 of them up in Michigan mainly now. Canada will be a thing that's coming, so that's, whether we go heavier than that, depends on what the code and territory you're in. So, any other questions about Piers or anything so far? All right, let's set a frame.
What we're doing here on a normal job site, when I get there, obviously the concrete's in the ground more sturdy. I would stand the vertical column on each side, and then we would bolt the 2 rafter pieces together. At that point, you can always tighten the top real easy with a wrench. We pick it up this far, then we can tighten the bottom. Now, on 30, 40 footers, we can pick up right here. When we get to the 60s, 70s, on up to 100, we will take lifting straps around here and put them to the forks. That, you're above it. There's a lot hanging out there that wants to bow. It's going to bow, but it will work. This being a show frame, we call it show frame, that's 1.5 inch angle. The normal angle is going to be 3 by 2, which there's a short frame over there. That's actually what it's going to be. So normally on a standard frame, there's going to be a 5/8 bolt, which takes 1 1/16 inch. We had, with this plate being smaller, we had to put 1/2 inch bolts in there. So that will be different than what you're seeing here. But
that being true on all buildings. Mainframes have 5/8 bolts. Endwalls have 1/2 inch bolts. So 2 wrenches puts the whole building together if you want.
I will not use this here. All I did was, when this is on the ground, whether it's 30 foot on up, every frame, put a rope on here that you're going to need a longer rope. We always go back 30 feet. You're going to go 2 frames back. That way you can, because this frame is going to stand in the air tied off with a rope while we stand the second frame. I'm just tying this rope on while it's on the ground, and we can go back. I'm just merely showing you what we do to hold that halfway straight, because you want that frame to be straight, because it'll want to lean on you, but then you put your board in the top, it's not sitting flat in the bottom of this clip. So you got to be halfway close to level.
Of course, the bigger the building gets, it might be 2 ropes or 3 ropes or whatever. Back a little bit, Zach. I got it.
You have to pull
All
that
right.
pier in.
Up, yeah. Go ahead, ceiling.
Up, Zach.
Typically, once you get the first frame set, we're going to tighten those anchor bolts up. Although the first bay takes a little bit of time compared to the other frames. This X brace is going to hook onto that anchor bolt. So we're going to take that nut back loose here in a little bit.
One thing I failed to tell you is these U-bolts are galvanized. There will be galvanized nuts. A regular nut will not spin on that galvanized.
Typically, we would, obviously, like Steve said, we would take this. We try not to go to this next frame because we're going to have to set red iron there. So we go back the next one just so it's out of your way. To see like this, they all bolt together really easy, but see how these two plates are not exactly. When you tighten them up, you want to make sure that you keep them plates lined up before you tighten them up.
Right or wrong, I always put the nut down on the bottom side. I've never had any loosen up, but my theory is if the nut comes loose and falls off, at least the bolt is in the hole to pin it.
Okay, once you get the first two put together, wind rods are made special for each building, not so much special. So this 15-foot bay, however tall the building might be, those rods are a given length. Wind rods are, they come in one bundle, but you need to separate them.
They weld an R in that for roof. Those have an S for sidewall.
It'll sort itself out, but roof is straight on both ends. End wall is angled on one end, straight on the other end. Sidewalls is angled on both ends. That's just like another set of rules that if you have a big building, you might have 100 rods. It's easy to kind of get them sorted out.
Because one X bay per 100 foot of building.
The first bay, we're going to get the sidewall in, we're going to get the roof rods in, we're going to put lumber in. And once this first bay is done, you could walk away from this building for months and it will not go anywhere. If the building is 300 feet long, we set the rest of the building and then go back and put the rest of the braces in. This side would be reminiscent of no overhang. So we made this side of the building have overhang, which is welded on. It's just a fascia board goes in that clip. Everything about the wood to metal is a clip. It's either a single clip or a double clip. Anything in the sidewall is a single, roof is a double, and we'll show you why here in a little bit.
Once you guys get to set enough of these, you'll get in the habit where Scott's at right now. the side X, the X rods that go in the side, always fasten on the second bolt down. That'll get you in behind the plane of the back of that 2x6 girt in the sidewall.
And I just told him I'm not going to bolt tighten that up.
Yeah, the second one down there, we know that there's going to be an X rod hooked to that bolt. We just leave it loose for now.
What's straight? Up there. Again, this inside anchor bolt's going to have an X rod hooked to it, so I'm not going to worry about tightening him up yet.
And a helpful piece of information, to get the building wider, we have the verticals already stood and you're setting the rafters up on top, you know, to set them up there. Rather than both of you fight each other, I always get a bolt in one side and then go to the other side. As soon as you get one guy moving, it wiggles on the other end. You can't get everything lined up. If we come over here, I got all my, what we call set boards. When you set a building, you're gonna have to have an L board at the eave, and about every fourth clip up, we call an intermediate board, and then a board up at the peak. Those are the boards. There's enough lumber in there, you can put your X rods in and get everything good and straight.
Those set boards, the goal is to just keep that 15-foot centers. So normally, like this 2x6 here, it's just there because we don't have a foundation. It's just spreading these piers. So when we put these X's in here and we start pulling on that, it's got something to pull against.
Now all I've done here is this top, what we call the top board.
So there's a board going to go right here. Well, on that side, it would be the eve board.
It's the center of the clip to center of the clip. We know that is a 15-foot dimension. I've already cut this top board to 15 feet. Now the bottom board, we took half, that frame is 3.5 inches. I went back 1 3/4 inches. That the bottom board, you'll see how it gets installed, will set against the inside of that iron. That way when we tighten up our X's, we've got something, we're not bowing the board.
We're just using that L board as the strong arm up here, that being the foundation, and then that's what the X's pull on. That's why once this X's are in, you can walk away. So all we're trying to do, I mean, to reiterate, I guess, that bottom board, the brace board, is just pushing on the frame angle. Whatever size the frame is, we don't care. We just know that dimension. You in? To begin with, we really don't drive these tight. We're just spacing is all we're doing. Now we're going to fill that up later. We're not going to get real involved with the next bay going south. But in the roof, everything is a double clip. 15-foot bays, 16-foot lumber. The goal is not to cut everything in the roof, so they overlap in these double clips. But when we get down here and we cut this top board at 15 foot, we need to fill the other side of the clip, as we call them scab boards. So this will go on just like so, and then that next bay board will sit right in here. Am I making sense? When you fill it's just easier to put the nails in if you fill the clip up. All the nails in the roof are 8-penny common. Commons are a thicker nail than a sinker. We're using that nail in a shear position. A common nail has a lot more shear than a sinker does, but you can use a pin nail or whatever it might be. In this, so in the sidewall as a single clip, we use pallet nails, spiral nails. I'm a little old school. I don't necessarily get on all the lifts like they do today, so I'll ride the frame. I'm up here on top of the frame. When you put the lumber in, you need a hammer in your hand to get it where you want to. It's natural for a nail, where if you're using a hammer and then a screw gun, you know, that's just a kind of a personal preference. Here would be a better example of, we put this board in here, and then this next bay, which we will set, that board will set in this other half of this open pocket once I get this all put together up here.
Real close where it's at, Zach. Now, if you look, I laid this to square these up. I've laid that level right on that webbing. This particular building, all this webbing is the same. Depending upon what size building, this bottom piece could be 1.5 inches. So you got to make sure that you're on the same, you got the same angle all the way up and down. Otherwise, you'll chase yourself forever.
Turnbuckles I always put at the bottom. Obviously, you can get to them from the ground. The roof rods up in the roof, you can put them wind rods up at the peak or at the eave. Obviously, the eave is just easier. It doesn't matter, but you can get to them easier to set the straighten things up. That is how we square the building up here in a little bit. Okay, I'm going to work on putting this eave board in. Steve will work on this one and show you what's what. But once we get that side looking like this side, and this is, you know, tight, and, you know, plumb it up when you're done, you can leave for the month. It won't go anywhere, no matter the building size. Now, obviously, we got to get a board in here, but once we get this first bay done, you're protected from Mother Nature.
Now, usually while they're, a group of guys over there putting the D-board in like they're going to, one guy can level this sidewall up.
Up there, I was using 8-penny nails, but this eave board, we got a single clip because there's only one board. So I switched over to what we call clip nails, which is just a pallet nail, only a simple.
People ask good questions, how tight to make these. You don't want them fiddle string tight, but you don't want them to move either. So there's a, but by putting that, now this is up. The reason we put that L board on the bottom of that, where that is touching that red plate, as we tighten these, that board that's up and down doesn't want to pucker out on us. Okay, while they're putting those X rods in, these are the next boards that are going to go up. And if you come over here, what we always call the intermediate boards, that's that on the bigger buildings, every fourth clip up, you're going to put one of these boards. This being so short, I'm going to put it in the middle. I've just taken a regular standard 16-foot 2x6. I come in 6 inches and I put a mark and I went to 15.6. Those marks are going to be 15 foot center to center. We put them in that clip up there. You use it, you get above it, and you can do it center of the frame or you can do it on the edge of the frame, but you got to be the same on each end. We're going to put that in that pocket, use 8 pennies, drive them in halfway and clinch them over. You understand why we're going to clinch them over for now. Once we get the next bay up, we'll take them out. Because if you don't clinch them over, when you tighten your X rods, you'll pull the nails. These next two are the peak boards. The peak board runs continuous all the way down the building. It doesn't stagger like the doubles do. So it means that the double clip up there, we have to put a scab board on it. I cut that peak board at 15 foot. That way we're running that continuous for the ridge cap. I always put this being the end, put a scab on this end. When they put it up there, that end, once again, they're gonna put their 8 penny nails in, clinch them over. That way when we put the next bay up, there'll be a scab on that end to fill that pocket up there. Once that's done, then we'll put the X rods in the roof. We'll have these sidewalls already square. We square the roof. On this building, yes, we can remove the forklift, be easier to work. On the wider buildings, it's got to stay there.
We use the term scab board, which is always a cut. It's always, 16-foot lumber, 15-foot bay. It's a 12-inch piece cut from whatever.
Do you guys sell much ridge light? Some? And it typically is wider. Ours is. Our steel ridge cap is like 12, and the others is 23 or 4 probably.
Yeah, I think it's just a few inches. I really don't think.
Well, that's what we were discussing right now. For us, where the pocket is located where they're at, the full board at the bottom of the clip is for steel. We would put that in the top of that clip for the ridge light.
Your way. Are you good?
One thing those guys did that I don't do, they can't. The ends of them X rods are on top of the frame. It's easier if you put them under the frame. The angle's too small, they can't get it. Because right here, when you put that first roof purlin in, that X rod being on top, you really got to force it down.
It's just the top angle of the frame, this being so small, there's not enough room to that wind brace end to go in there. Does that make sense? On a regular building, this wind brace would be on the bottom of that angle, not on the top. There are times when the only place to put a brace bay is in the corner on the end wall. But it's hard to set that bay first. You want to set a mainframe to mainframe. So then we're going to set that mainframe, put these rods in and finish the building. And then we're going to take that set of rods, because there's a door here, and move it down there to the corner.
Now that we have that side level and this side's level, the roof rods are in. You stand back, you catch this edge of that leg and go to the leg on the other side and follow it up to the peak. You can see whether the peak's got to go one way or the other. And that's how you would adjust those rods accordingly to bring the peak over. Now, you've got to watch. You can get them rods too tight, and the peak boards want to do that. So you got to there's a happy medium there.
Usually when you get done, at least when you get done putting the lumber in, or maybe when the building's completely done, covering and everything, we'll go back and make sure the rods, one, aren't too tight, but most importantly, aren't loose. Because sometimes you could be level and it's really not snug. As long as it's level when you put the covering on, it's fine. You need to go back and that's just going around to the turnbuckles and snuggling them up. I call it don't get crazy. Snug, not tight. We've got people that have tried to break anchor bolts off because they're pulling so hard,
When you've got that pier box on there, if something happens in that let's just say the top of that pier gets poured in just a little, not level. You stand that vertical, like I told you, that leg wants to flop in. Easier to loosen them anchors up and push the top of that leg out when you set your rafter on top. And any of these, don't get crazy cranking on them real tight, because if you get 20-foot leg, you got a good pry bar there, you got a good chance of, you will snap some concrete out more than likely.
In today's world, 99% of the time, you're going to be setting the legs and then setting the rafters on top of the legs. You're not going to be setting it one piece. That's just the size of the building now. That's how it is. So when it comes to end walls, there's just generally speaking, the pieces are more specific. There's always two end walls to, well, not always, but mostly there's two end walls to a building. There will be an A or a B welded in the appropriate pieces. So at least you can get the B's down there and the A's down here. That's half the battle. Then like that corner post and this corner post, there's a left and a right. This door jamb post and this door jamb post, there's a left and a right. They're virtually the same post, but there are lefts and rights. So you gotta kind of lay it out a little bit. And then the same way, since we have no overhang on this side of the building, we have overhang on that side of the building, the rakes are left and right also. This eave board, that eave board, the top was 15 foot. When you get to the end of the building, the top board is 14, 10 and a half. The rake board, which is going to go across the end of the roof purlins, inch and a half, that's where we get our 15 foot. The bottom of the L is a different dimension than that because we're 15 foot from the center of the frame to the end of the building, inch and a half beyond the red iron. So we need to get back to the inside of the red iron for the bottom board dimension. So the rake, the C-section, rafter if you will, rake, bolts on the inside of this post. And the board, the bottom board is against that C-section rake. So we have 2.5 inches. End wall openings, it's a little 8x8. If it's a door in the end wall, it's always going to be framed out of steel. If the door is wider than 16 foot, it'll have a webbed header, not a C-section header. There'll be posts above the door. So on a big, if we got a, we're used to having 40, 50 foot openings, and we got to support that rake above. So that header is also a door header, but it'll also support the roof above. So that post he's holding would never be on this door opening. But
On a wider one.
it's made to bolt to the header, and in this case, if it's a center post, it'll bolt in between those two center plates. If it's an intermediate post, in other words, not on center, it would bolt just like this post here. It would sit here, bolt, and go up beside that and bolt into the side, just like this post does. On any door that is over 16 feet wide, you would have posts above. The same thing applies. 15-foot bay, generally speaking. 15-foot bays, posts in the end wall are a maximum of 15 foot. So if you have a 60-foot wide door with a 60-foot wide building with a 30-foot wide door centered, you're going to have a door jamb post and a door jamb post and girts out to the corner. If you have a 60-foot building with a 24-foot wide door centered, you got more than 15 foot beside the door. So then we're going to maximum spacing of 15 inches or split it up evenly under 15. That's the rule on anything. So like on a blank, an example would be a blank 40-foot end wall, no doors. The posts are on 13-foot 4-inch centers. On a blank 60-foot building, the posts are on 15-foot centers on the end wall. Just can't go over 15.
And anywhere there's a post like that on top of the header, there'll be a kicker brace that goes to the header, to the top of that frame to help support the wind load on that header.
As you guys can see here, we purposely made that board. That's how I was asked earlier how to do the overhang. The double board up there, we made it longer. That's a 1-foot overhang. You could do the same thing with a 2 or 3, 4, whatever you would like to do with that scab board, if you will.
Like I was saying earlier, a 12-inch overhang is you just take that 16-foot lumber and stick it out. Anything more than 12-inch, that board's going to come to here, and then you cut. If a 2-foot overhang, I cut a board 4 foot, 2 foot back in, 2 foot out in the other half of that clip. So the scab board gets to be 4 feet long for a 2-foot overhang. If there is no overhang, then the scab board is just like that. It's just adding and subtracting. Small buildings, 40 foot, so 14-inch frames. You know, as I said, we got a 14-inch frame, a 24-inch frame, and a 36-inch frame. 14-inch frames and down, so 40 foot wide and down, gets 6-inch C-section. The end walls are all 6-inch. 50 and up is 8-inch, because then sometimes it'll be a piece of C-section, sometimes it'll be a piece of tube, square tube, sometimes it could be an I-beam, but the 8-inch dimension is a common, because the bigger buildings, that post gets to be substantially longer, and we have to make it, that's not substantial enough for a 28-foot tall post or whatever.
One thing to always remember is that rake C always bolts on the inside of that post. Because you can put it together the other way, but when you start getting framing outside, nothing's gonna work. And likewise, these clips, that strap always covers the the open part of the C-section. Because you can have it on the other way, and the clip looks like it's gonna work, but when you get out here framing, it's not gonna.
We can't level it up, but obviously there would always be a brace at the corner like this. So if we had a blank end wall with a 15-foot, if you want to call it bay, that brace would go to that next pier or that next anchor bolt, whatever that dimension is, that brace would be made for this, appropriate end wall.
And once again, it's on the inside bolt, that way it clears the back of that 2x6 when that 2x6 is put in there.
If you want to change, so this building has 12-inch overhang over here and standard girt spacing, which is 41.5 inches. I really don't know where that dimension came from, other than it's always been that. Popular nowadays, that side we put the girts on 2-foot centers because you can put a sheet product on it. Insulation dimensions are better and that nature, and it doesn't cost much money, just a couple more boards, really. But, so there's a couple different things going on here.
While we're on this end, this is a display frame that is going to be here, showroom or not. This here is, we call this a V-brace. It can't work on that frame, so we're gonna show you on this guy here. All it's doing is, that notch is going around that, and we're pulling it up, and we're gonna nail this to that 2x6 purlin. All this is doing is keeping that frame straight up and down. The way when the wind wants to push on it, it can't do that. Basically, you're going to put this as low as you can get it, which is about the first clip up, as high as you can get it to the peak, and then split the difference. Once you, on a 40-foot frame, there's going to be 2 on each half. What's that? Yes, every mainframe. A 50 will have 2 on each half. A 60 jumps to 3 just because, you know, it's the longer span. We're just trying to keep it straight. This end is different. It's got another short piece of angle that bolts to it, so you can bolt that up into the
V-brace. The V-brace is the same. It just, there's an additional bracket for liner applications. You just drill a hole, and then you bolt it to that bracket that's lagged to the ceiling, the bottom of this purlin.
Step over here. I'll show you what I did here. We cut that tab to cover half of that frame on each end. Also, there's 1.5-inch spiral nails. There's 4 on top, and there's 4 on the bottom. You want to have that back of that pocket as tight to that board if it gets lined. If there's a gap back there, it makes a heck of a step in there. So,
Fairly popular. The guy builds what we call a mainframe endwall, just like this, and he wants to put a wall there, but he knows he's going to make the building 100 foot longer in 5 years. We'll put these posts in there, and then he can just take the posts out and keep on going.
if you got a guy who puts up a standard building, like a standard end walls on both ends, and 5 years down the road, he wants to add 60 feet to it, you can, done it. We'll make a frame to shore up the roof. You take the end wall out and you put a main frame in its place to continue on. Quoting purposes, it'll take 4 guys a day to take that end wall out and put the main frame in its place.
It's not hard, it's just a lot of labor. Another thing that is popular in a non-commercial building, non-state stamped, so you got a farmer and he has an end wall with a door or blank, whatever, and he wants to just make the building longer, but he wants to leave the wall here. If you leave the siding on it, just go on. If he wants to, you can't take the siding off and have that end wall support the next bay. But that's happened a lot on the farm where they might have a 30-foot door and then they build another 100 foot and that's their storage and they turn this into the shop and they just want to bring things into the shop through that door. That happens a lot. Well, if you're still here, that means you watched the whole video. Thanks for staying with us. As you see, there's not really mystery to putting this cave building together. New crews sometimes overthink it and make it more complicated than it is. But at the end of the day, it's simple, efficient, and easy, especially for the big buildings. K-building frames are pre-engineered and go up quick. Once the brace bay is set, you can walk away and Mother Nature is no longer a worry. Then your crews can add all the things your customers want, like porches and lofts and lean-tos and all the fancy pretty stuff. The K-frame handles the big load and you handle the finishing touches. It's faster, cleaner, and just makes the whole job go smoother. When you're ready to quote it or you have additional questions, contact your supplier for more information.